Parthiban sir. Okay, let's introduce. Very good afternoon, dear students and my colleagues, faculty members. Okay. So, in connection to our previous discussion related with basics of design of transmission systems and what are the various topics which we are about to explore in design of flexible elements, that is in first unit, and we have also seen the design procedure of flat belt drive. We have commenced with flat belt drive. I have even suggested you to work to design a flat belt drive with a question from the university question paper which is provided. Okay. I hope you have solved it. If you have already completed it, please recheck it during this session. And if you have not even commenced it, if you have not even joined in the Google Classroom, I request you to join in the Google Classroom. And I request you to follow the first problem, the first design problem in each and every individual topic. That seats, that makes sense for you to understand the complete design procedure. And remaining all the problems is about some differences in the input, some differences in the various parameters related with the, that is changes in choosing a specific criterion related with the design problem. It is about to understand where to take the data and how the sequence is being followed. Okay, so I request everyone to pay attention. Okay, so we have discussed this. The design procedure of flat belt drive involves this 8 steps. We have also seen the 8 major steps. And as I said earlier, this will be the team. I will provide assignment questions, and meanwhile, at some time I will used to ask questions. We will treat this like a game. I used to calculate the scores for individual teams. Okay, we will work on this. Okay, these are the procedures. I hope you have seen it. And this is where we have concluded in the previous session, and I have even provided this as an homework. Already you are in home, meanwhile a classwork in your home. Okay. So the part B, first question. We will commence the session by designing a problem to this, designing a solution to this problem of flat belt drive. Okay. So I'll read out the question. Select a flat belt to drive a mill at 250 rpm from a 10 kilowatt 730 rpm motor. Center distance is to be around 2000 mm. The mill shaft pulley is of 1000 mm diameter. Okay, it is clearly mentioned. It is flat belt drive, which is operating for an application of milling application. Okay. Here they have provided the speed of driver and driven. As I have already mentioned, the driver or driving pulley, the notations can be, I suggest you to look upon this notation because it makes sense. It looks similar, when compared with other thing which you may refer a different text. Okay. So the smaller case n and smaller case d refers the speed and diameter of driver pulley, and the larger uppercase n and uppercase d represents the speed and the diameter of driven pulley or follower pulley. Okay. So here you have to read the question properly. Here one of the important things students used to make the mistakes is they fastly interpret the question and take the data in a wrong sense. Okay. So here a flat belt drive to drive a mill at 250 rpm from a 10 kilowatt 730 rpm motor. So the motor runs at 730 rpm and the rated power provided, the rated power for this design is 10 kilowatt. And they have also mentioned the speed of driven, which is 250 rpm, and the center distance is provided. Center distance is the distance between the centers of both the pulley. Okay, between the center point of driver pulley and the center point of driven pulley, we used to measure the center distance, which is 2000 mm. Okay, and the mill shaft pulley is of 1000 mm diameter. Mill shaft pulley, which is the application end, which is driven pulley, which is 1000 mm in diameter. Okay, and here we are need to initially calculate the diameter of what? Driver pulley. Okay, so the step 1 commences with what? Selection of pulley diameters. Okay, selection of pulley diameters. What we used to utilize the velocity ratio equation. We have seen velocity ratio, which is speed of driver divided by speed of driven, which is equal to diameter of driven divided by diameter of driver. Okay. So based on the given conditions, that is the speed of driver, driven, and diameter of mill shaft, we can calculate the smaller d. Okay. So here I have solved it. I have just typed based on the question which is solved it, but and if maybe I need your interaction in the forthcoming problems and the forthcoming design problems. You are supposed to provide the solutions in each and every step. Okay. So I hope up to D. Now this D is 342.46 mm, which is the calculated diameter. Now, as per the procedure we have discussed, we used to take up what a recommended pulley diameter. Okay, how do I calculate? From page number 7.54, I used to take up recommended pulley diameter. So page number 7.54. Hope you have taken the printout of page number as I have suggested earlier. Okay, so recommended series of pulley diameter. You have to refer this table and you have to choose the appropriate one. So since here it is 342, always it is preferable to take the nearest maximum one, which is 355. Okay. So meanwhile, whatever the value which you get based on the calculated diameter, you have to choose the standard recommended series of pulley diameter. Okay. So since we have got the diameter of driver pulley as 355 mm. And the second step is for flat belt drive, it is calculation of design power. As I said, design power is the a maximum safe operating power which is needed for your design. This design power consists of various load condition and the corresponding working environment, different working conditions for the drive, belt drive. Okay, so we know that design power we can calculate by using the equation, that is a product of rated power, that is a given rated power, with the product of load correction factor which we used to correct it based on the different application where the specific component is being utilized, and the arc of contact factor. What will be the arc of contact which has been taken place? Okay, as I said in the previous session, arc of contact. What is the arc of contact? The angular contact which exhibits between the pulley and the belt. Okay, so the pulley starts touching the belt starts touching the pulley from this point and it leaves at this point. So I used to calculate what will be my angle. So this angle of contact or arc of contact is to be calculated such that the corresponding factor based on the data book, we used to make the product of that factor. Okay. So here okay, so rated power which is given in the question 10 kilowatt, and the load correction factor. How do I calculate load correction factor? I hope you did this. Here load correction factor I have chosen it as 1.3. Okay, from page number 7.53 you can choose the LCF, that is load correction factor. Here in the question it is mentioned as for the application of milling. Okay, so you have to refer the question based on which application it is provided. Okay, if it is for either different printing machineries, if it is for heavy load application, if it is for compressor, evaporators, you have to choose the corresponding load correction factor based on the application provided. And you may ask me, sir, what if some application is not provided? There is no, it is just simply a flat belt drive. You can choose whatever you want. It's just assuming the corresponding application. Okay, so here it is. So the load correction factor. Okay, so here you can refer sawmill and paper mill machinery in the intermittent loads. Okay, sawmill and paper mill. Okay. So based on this, I am choosing 1.3 as the load correction factor. Okay. So now, after load correction factor, arc of contact factor. How do I calculate arc of contact factor? From page number 7.54, you can get the values of arc of contact. Okay. First, you have to calculate what will be my angle of contact. If you are using the data book, please follow from page number 7.54. Okay. So there is an equation for calculating the arc of contact. Since it is open belt drive, here it is 180 degree minus of d minus d by c into 60. If it is open belt, if it is cross belt, there will be more angle of contact. There will be more arc of contact. So there it is 180 plus d by c into 60. Instead of minus, it will be plus. So by using this equation, we used to calculate the degree of arc of contact, and then we used to take the suitable corresponding factor for what? Calculating the arc of contact factor. Okay. Okay. So arc of contact, we are using this equation, and if you are finding this 180 d minus d by c 60, I am getting the angular contact of 160.65 degree. So if you refer page number 7.54, you could get what is the for 160. Okay, what is the correction factor for 160? It is 1.08. Okay. If you are getting it is like say 175, you can take some values between 1 and 1.04. It's up to you. Okay. Or you can take some nearest value. See here, the objective is to make you to understand the design procedure. It is not exactly similar, some point, not some decimal answers. Okay. It is not the matter of sense here. We used to just observe whether the sequence of procedure is being properly followed in order to design. Okay, design an element. Okay. Yeah. So for this value of 160 degree, we have got the arc of contact of 1.08. Okay. So now we are just calculate the design power. Design power, the product of rated power, which is 10, load correction factor Ks, which is 1.3, and the arc of contact factor, which is 1.08. I'm getting an answer, some value of which is 14.04 kilowatt. Okay. So the rated power is 10 kilowatt, but my design, which inculcates based on the loads, based on the working condition and the arc of contact, I am representing the design power as 14.04 kilowatt. Okay. So we'll move on to the next procedure, next step, which is selection of belting. How do I select a belt? Okay. I said it is based on the given conditions. As I said, referring the page number 7.52, either you may choose this based on if it is heavy load or if it is okay medium load. You can go behind that one for selecting a suitable flat belt. So here you may refer for see here you may refer it is light and medium duty. Okay, if it demands light and medium duty, you can select Dunlop high speed 878G fabric belting. Okay, if it is heavy duty, okay, you can go for Dunlop Ford 949G fabric belting. And you may ask, how do I classify light and heavy duty? This you may even witness the corresponding load correction factors. Okay. In the load correction factor, if it is normal load and steady load, consider this as light and medium. And if your application, your design demands intermittent loads and shock loads, you can go for consider it as a heavy load. Okay. So based on this, considering this as heavy duty, since milling comes under intermittent load, okay, the application demands intermittent load. Considering heavy duty, we are selecting the Dunlop Fort 949G fabric build for this design. Okay, clear? Then we will move on to step 4, load rating calculation. What is the load rating calculation? In the sense, the dispersion, the distribution of load in terms of number of ply and individual per ply. That's why the unit of this load rating can be mentioned some value, some constant value in terms of kilowatt per per ply. Your belt may consist of 4 ply, 5 ply, or 6 ply, and how this load is rated in terms of per in 1 ply. Okay. So this for this, excuse me, getting some messages. Okay. Monish. Okay. While selecting, I have a message. Okay. While selecting load correction factor, mill is given as 1.5 sections. Not sure. Kamlesh? Wait. Yeah. See, it is about you can choose because it is they have not mentioned it here which type of mill you are going to opt for. Let me check. Okay. See, load correction factor. See, Kamlesh, you can see here it is rolling mill, here it is sawmill and paper mill machinery. I'm just considering it as sawmill or paper mill. You can, that's not an issue either to go with intermittent load or shock load. Consider, but whatever you are considering, just try to mention in your answers properly. See, I have considered the design as intermittent load since the mill is alone provided in the question for designing the flat belt drive. So I have considering it as sawmill, okay, or else paper mill. Here, what you are justifying is like ball mill or rolling mill, something else. Okay. That's not an issue. You can go behind anything. It is preferable to adapt with the question specific application provided. I could mention here it as considering sawmill. Okay, that's not an issue. If it is no application is provided, you can go behind any of this. Okay. Is there, there is any other questions? Okay. Fine. Okay. So for load rating calculation, step 4, I have said you to look upon page number 7.54. Okay. In the 7.54, you have got an equation for load rating at V meter per second. This V is like your velocity meter per second, which is equal to load rating at 10 meter per second into V velocity by 10. Okay. For this load rating at 10 meter per second, we have got the value which is provided in the data book, page number 7.54 itself. Okay. Here you could refer the load rating, okay, per mm width per ply at 180-degree arc of contact at 10 meter per second belt speed. So we are going to use this equation to calculate load rating at V meter per second equal to load rating into 10 meter per second into V by 10. Okay. This load rating at 10 meter per second is the value for your corresponding belt which you have selected based on the given inputs, based on the application, either it is heavy duty, steady or light duty. We have selected for 949G duct belting. So I am going with what? Again, if the power is mentioned in kilowatt or horsepower, even if it is horsepower, try to convert that into kilowatt. Here, power is mentioned in the question with the kilowatt. So it is 0.0289. Clear? So load rating at 10 meter per second for Ford 949G fabric belting as provided in the data book. I'm taking it as 0.289 with the what velocity of the belt. Okay, divided by 10. I need to calculate the velocity in terms of meter per second. Just using the velocity. See here, this load rating we are considering entirely for driver. Okay, so pi dn by 60. Since d is in millimeter, I am converting in the. I'm taking the velocity in terms of meter per second. Just I'm providing 1,000 in the denominator. So diameter of driver pulley 355, speed of driver pulley 730. So my velocity is 13.56 meter per second. So now apply this in the equation provided, which is load rating at 13.56 meter per second equal to load rating at 10 meter per second and 13.56 by 10. This value is 0.0289 kilowatt, which we have taken from the data book from page number 7.54. So my load rating is, value of load rating is 0.0391 kilowatt per mm per plane. Okay, this is step 4 load rating. Okay, then we will move ahead to step 5, determination of belt width. We used to determine what will be the belt width and then pulley width and then length of the belt. For determining the belt width, we are supposed to use the equation, which is design power divided by load rating into number of plays. Okay. Already we have calculated the design power. Already we have calculated the load rating. Now I am in need to find the total number of plays which my design, which my belt requires. Okay. For this, we will be depending upon page number 7.52. Okay. Considering the velocity and considering what the d value, diameter of driver pulley, we are about to choose. We are about to select the total number of plays. Let me show you. Okay. Go to page number 7.52. Okay. See the bottommost tabular column. Okay. Bottommost tabular column. So here for the velocity of 13.56. Okay. 13.56. Choose the. So here it is given for the velocity of 10, 15, 20, 25, 30. It is 13.5, 13.5. So the nearest standard velocity provided is 15. Okay. So for this 15 velocity, for the diameter provided here, okay, corresponding minimum pulley diameter provided here. So the d value of 355 mm. So it is 100, 160, 224. Refer this column alone for the velocity of 13.56. We are selecting the 15. In this column, I'm going to look upon the d value of 355. 355. So here it is what? The nearest one. I'm selecting the nearest one, which is 315. Okay. You may ask me, what if I am selecting the maximum one? Because always it is preferable, as I said, always it is preferable to go for the next standard value. There is no issue in that. There is nothing wrong in that. Yeah. Again, I'm saying we are looking behind the procedures. It is not numerical value, and it is not going to change to a very a larger one. Very major changes won't be occurring in the final result. Okay. So you may go for number of plays as 6 or number of plays as 8. Since there is a last difference between 6 and 8, my 355 dia 355 shoots with number of plays are 6. Okay, already the velocity is 13 and 355. So I am selecting the number of plays as what? Taking or assuming the number of plays as 6. Okay. So taking number of plays as 6 value, I do have the design and I do have the value of load rating, and I have what? The number of plays. Based on this, calculate the width of the belt. So after calculating width of the belt, I need to standardize the width. Okay, I need to calculate the nearest standard belt width. For this, refer page number 7.52 again. Okay, in the 7.52, okay, for the corresponding 6 ply, Okay, 6 ply belt. Okay, go for the next standard value. Okay, so here I have calculated values. It is 59 something. Though, so the nearest standard one, that is the starting one, is 100. Okay, let me show you. Okay, so in the 6 ply you could refer 59. It starts with the standard belt width starts with 100. You can go behind this 100. So we are the standard belt width is taken as what, 100 mm. Okay, clear, simple as it is. So next we used to calculate pulley width of the pulley. How do I calculate width of the pulley? Based on the belt width. Okay, so you just remember how the pulley and the belt will be just passing across the surface of the pulley. So my width of the pulley should be slightly wider than the width of the belt. Okay, so refer page number 7.54. Page number 7.54. This last tabular column. Okay, you could see that pulley width, for pulley width, refer the belt width up to and including 125 mm pulleys to be wider than the belt width by 13 mm. So based on this, we have got the standard belt width as what, 100 mm. Okay, so here I have to add this 13 towards the 100. Why we are doing this? The pulleys to be slightly wider than the belt width. Okay, clear? Okay, so pulley width equal to belt width plus 13. This 13 is not a constant one. This we are selecting based on the belt width which is obtained using the data book page number 7.54. So I have calculated the pulley width as what, 113 mm. Now I am going to standardize it. I am going to take the standard pulley width from page number 7.55. Okay, from page number 7.55 I need to take the standard pulley width. Let me check. Okay, so here you may refer yeah, recommended series of width of flat pulley. Okay, so the calculated one is 113. Okay, so you may go behind selecting 112 is available and 125 is available. You can choose any one of this, either 112 or 125. Always, as I said, it is preferable to choose the next standard one as the highest one. And there is no wrong even if you choose, since 112 is near, very much near to 113. Not at, there is no issue. Okay, you can actually you can choose any one of this, either 112 or 1. The thing is, you have to standardize. You have to follow this procedure of choosing the standard pulley width from page number 7.55. Okay, so after excuse me. Okay, so after calculating the pulley width, we have standardized the pulley width. We have chosen the standard pulley width and it is 125 mm. Then the last step, which is calculation of length of the belt. How do I calculate the length of the belt? Is using an equation from page number 7.53, which is 2c plus pi by 2 d plus d plus d by d minus d whole square by 4c. Okay, so for 7.53, if you choose 7.53, in 7.53 page number, you may refer, it is belt length. They have provided for open drive and crossed drive. For cross belt drive, you have to choose the corresponding equation for cross belt drive. There's only the difference is here, instead of minus, it will be plus. Okay, addition. Since cross drive consists of more angular contact. Okay, so I'm choosing the open drive, open flat belt drive length calculation, length of the belt calculation. Okay, the equation to calculate length of the belt. Okay, based on this, we will calculate it. We have all the data to calculate this. It is center distance, diameter of driven, and diameter of driver pulley. And meanwhile, yeah, that's it. Just direct substitution. Okay, you may get the length of the belt. Okay, that's it. Specification, you have to write, as I said, each and every specification. Write the type of belt. It is Dunlop 4949G fabric belting, and the belt width, again pulley width. This thing you have to write the standard one, not the calculated one. You have to write only the standard one. Length of the belt, number of plies, diameter of driver pulley, diameter of driven pulley, center distance. Okay, so very simple one. If you are able to understand how do we take the data correctly, it is very easier. Okay, we will have just 2 minutes. If you have any doubts, please. Okay, if there is any issue with voice, Rahul Ganapati raised a question. Okay, thank you. If you have any doubts, you can represent, you can even unmute or post a message in chat box. I hope you have understood the simplest one. See, in the first chapter, a very simplest one to design is, which is flat belt drive. And then next is wheel belt, next wire rope, and finally the chain drive. Chain drive is very easy, but it consumes so much of time, up to 15 procedures, 15 steps. 15. Here it is just 7 steps. And I forgot to say that here we do got step 7 slide. Okay, I'll show the step 7. Here we have designed only the flat belt. Actually, the drive represent the corresponding pulley also, but there is no necessity unless it has been mentioned in the question to design the pulley. We will just look upon another type, which is cross belt drive along with pulley design. Okay, even. What I will do is I will always prefer with the equation, formula, units, which has been with the data book. No need to interpret with so much of conversion. Okay. Yeah, let us proceed. I hope if there is any other questions. Okay, fine. We will proceed. Okay. Step 7, I will show step 7. Length of the belt. It is just a direct substitution of center distance, diameters of driver and driven pulley. We are taking the exact length from the data. I used to follow most of the equation, most of the notations as it is represented in the data book, so that it makes sense if your exam is like as per regular, it is offline. It will be very easier for you to look upon the equations and just take it directly, because most of the books there will be differences in equations, difference in procedures. Okay. Okay. Step 6 also. Determination of pulley width. Okay. We have calculated the belt width, and from page number 7.54, as I said, the pulley width of the pulley should be wider than the width of the belt. So based on the belt width, so you may refer that in the 7.54, it is mentioned as up to 125 mm. The pulley should be wider than 13 mm. Okay, like that. And later at the next stage, maybe wider than the 25. So I'm just adding the belt width towards the 13 mm and standardizing. Okay, from page number 7.55, the tabular column in the left, I am standardizing. I am choosing the next standard value. You may even choose this as 112, no issue. Okay, no problem with this. Okay. There is no one to check your answers are exactly, it is some 125.3 or like that. Okay, no, that won't make any sense. They used to observe whether the sequence of procedures are followed properly, units are mentioned, the data books are properly referred, and the values are standardized. Okay. Ram Kumar, step 3 slide unit. Okay. See, no issue. We will sort it out. You may ask any doubts, because the first question in any new topic, that should be properly cleared. Okay. if you are understanding based on a design procedure in first question in a new topic, then it is this course of transmission systems is very easy. Okay. Step 3 slide, I said like we used to just select the belt for flat belt based on that is for learning purpose. Here they have provided two different type of belt. One is Ford 949G fabric, no, another one is high speed 848G. Okay, if it is heavy duty, we are going behind Dunlop Ford 949G. Even that is mentioned in the data book page number 7.52. Okay, if it is light duty or normal, that is not heavy load. That's what I used to, I said you to prefer this based on load correction factor tabular column. Okay, if it comes under first two, okay, light and steady, medium, go for high speed belt. If it comes under next one, intermediate load and shock load, okay, you prefer to choose the Ford 949G fabric belt. Okay. Any other questions? Shall we proceed to the next problem? We will look upon another one problem. I prefer to choose different types of data, different problem, and I prefer to provide homeworks or assignment if there is a same data. Okay. We will just discuss with some other cross belt drive along with pulley. Okay. We'll move on to the next one. Okay. Come again, concentrate. Okay. So this is another one problem, another one university question. So a stone crushing machine. Okay, the application, it is clearly mentioned. It is stone crushing machine. Receives power from a motor rated at 50 kilowatt. Okay. Receives power from a motor rated at 50 kilowatt. Rated power is, sorry, this is a mistake. Please don't mind because I have not edited it properly. Power is 50 kilowatt. Don't take it as 10, it is 50 kilowatt. Okay. And at 1800 RPM by means of a flat belt. So how do I consider the major mistakes student used to make is considering the speed as either it is driver or driven. They used to interchange the speeds by misunderstanding the question properly. You have to read it again and again. Stone crushing machine receives power from a motor. Okay, motor is a driver rated at 50 kilowatt at 1800 RPM. Normally the motor used to consider it as a opinion. It is a smaller pulley. It used to run at the maximum speed. On the application end, it is a larger pulley. It used to run at a minimum speed. Okay. So N, the smaller N, lowercase n, 1800 RPM, which acts as a driver by means of a flat belt. Okay. The pulley diameters are 200 mm and 700 mm. Okay. The diameter of driver pulley it is 200 and the diameter of driven pulley it is 700 mm. Center distance between the two pulleys is taken as 4000 mm. As I said, the center distance is 4000 mm. Okay. Design the belt drive along with cast iron pulley. You have to refer this. If you are getting a question like this, maybe for the past 4 years, I have not got one question mentioning the student, requesting the student to design the flat belt along with the pulley. Okay. But if you are very unfortunate, you may be facing this question of, because it consumes time to another, we have to focus on some 3 to 4 steps, smaller steps to design the pulley. But as per the procedure, as per our curriculum, you are supposed to learn designing the pulley also. Okay. So here it is clearly mentioned, design the belt drive along with the cast iron pulley. See, if the direction of rotation of the two pulleys are opposite to each other, you have to understand this. They have not explicitly mentioned here that it is a flat belt, a open flat belt. Okay. So here flat belt is mentioned. There is no idea about whether it is open or cross. They have not mentioned. See, but listen, if the direction of rotation of two pulleys are opposite to each other, you have to understand that it is a cross belt. Okay. Then allowable shear stress for the shaft may be taken as 120 Newton per mm square. This is for designing calculating the diameter of the shaft, we used to use what? Shear stress equation. Okay. So we will proceed this. We have taken all the given condition. The initial thing before you commence to design based on the problem constraints provided is to just extract, interpret, and extract all the given inputs clearly without any mistakes. Okay. So then cross belt drive. I hope you have understood about cross belt drive yesterday. So here they have mentioned the direction of rotation of two pulleys are opposite to each other as exactly consider the smaller pulley as driver. So tight side tension, it rotates in the clockwise direction. Since it is a cross drive, okay, instead of open, here we are crossing it. So it it changes the rotation. Okay, so the rotation of two pulleys are what? Opposite to each other. Okay. We will proceed this. Please solve along with me. I need you to interact. I need you to respond with the answers. We may have tutorial session, but I need you to practice. Okay. So similar to the previous step, first one, selection of pulley diameter. So here I don't want to use the velocity ratio equation and so on. Why? In the sense they have directly mentioned what? The diameter of driver and diameter of driven pulley. Okay. So I'm just writing it directly. Okay. Next one will go on to calculation of design power. What we have to do, the rated power is provided. Okay. Since you used to calculate, the rated power, you have to change it. It is 50 kilowatt. If there is a mistake, please change the rated power as 50 kilowatt. And load correction factor. In the load correction factor, please refer page number 7.53. How we have to proceed for choosing the load correction factor. We have to refer in what application a flat belt design. Okay. So here it is stone crushing machinery. Look for the specific application provided here. So it comes under shock loads, that is heavy duty, and the load correction factor for a stone crushing machinery it is 1.5. Okay, consider 1.5, and it is heavy duty. As I said, if it comes under normal load and steady load, consider it as light and medium duty. If it is intermittent load and shock load, consider it as heavy duty. So for normal and steady load, I used to select high speed, Dunlop high speed belt. Here, heavy duty 4949G belt, which helps in the next step. Okay, here they have mentioned the crushing machinery. I am selecting the load crushing factor of 1.5. What if they have not mentioned any application? You can choose any one of it, no issue. You can go for either steady load or intermittent load. Just mention, you can either choose compressor, it is a grinder, it is automatic machinery. Just mention whatever if you are choosing it. Okay. So we have taken the load correction factor for crushing machinery and arc of contact factor. Okay. For arc of contact factor, I have to refer page number 7.54. As I said, the important thing here we have to please note down these changes for open belt and cross belt drive. For cross belt drive, for arc of contact, there is smaller changes in the equation which we are going to use in order to calculate the angle of contact which takes place between the belt and the pulley. So 180 minus D minus D. Instead of minus and minus, we used to calculate addition, plus and plus. Okay. Okay. Referring page number 7.54. Okay. Page number 7.54. Here in the data book, we have got only arc of contact for, this is for open belt drive. But for this, don't use the similar one for cross belt drive also. I have seen most of the mistake in this, because let me explain this. So you may observe here the angle of contact exhibits between the open belt drive and cross belt drive. In cross belt drive, we do have maximum angular contact, more angular contact when compared with the open belt drive. See, in open belt drive, we do get an angle of this one. Okay. It will be around 180 something else. In cross belt drive, we may have more angular touch. Okay, the belt touches or passes over the pulley in the more surface. Okay, and that is why we are, instead of minus, we are here, it is mentioned as what, plus. Okay, so using this, calculate the angle. Okay, if I am calculating the angle, I get an angle of 193.5 degree. So for this 195.3, the arc of contact factor, it is 0.96, referring the tabular which column which is provided in 7.54. Okay, okay, 196. I'm choosing the next one, which is 0.94. Okay, you may also what, make an iterate here. We may also choose 0.95, 94, 95, 96, and 97. Okay, since it crosses 195-degree, you may also choose 0.95. If you don't want to waste time in what, in focusing more on exact result, there is no issue. It is not with the answer, it is with the procedure. It is making you to understand the procedure. You can wisely choose 0.94, the arc of contact correction factor. Okay. So for calculating the design power, we have what, identified, selected the load correction factor, arc of contact factor, and already the rated power is given in the question. So please excuse me for this mistake. It is 50, it is not 10. Okay, it is a typo error. Okay. So design power equal to rated power, load correction factor, and arc of contact factor. So I'm getting my design power, which is 72 kilowatt. Okay. So what is the next step? Selection of belting. How do we select the belt? As I said, based on type of application it is provided. Here, what? It is shock load. Okay. So just like the previous problem, considering it is shock load, heavy duty, stone crushing machinery, Dunlop 4949G fabric belting is selected. Okay. Again, yeah, I will refer page number 7.52. Okay. So there are, as I said, two different type of belt. Either you are going to choose this based on light or medium duty, or based on heavy duty. For light and medium duty, the first type of belting, Dunlop high speed 878G fabric belting is recommended. And for heavy duty, okay, Dunlop 4949G fabric belting, the second one is recommended. Okay, and there ends our step 3. Okay, step 4, load rating calculation. Okay, just like the previous problem, we do have an equation to calculate the load rating at V meter per second equal to load rating at 10 meter per second with the product of V by 10. And we have selected what? 4, that is 4949G fabric belting, 0.0289 kilowatt per mm per ply is the value for what? Load rating at 10 meter per second. It is provided in the data. Okay. So I may need to calculate the velocity. Okay, velocity of the belt. So velocity of the driver, I have a diameter and the speed of the driver pulley, and I have calculated the velocity of 18.84. Just substituting the velocity value in the load rating equation, I am getting 0.0544 kilowatt per mm per ply is my load rating. Okay. Once again, I'll show this load rating calculations in the 7.54 data book. Okay. Okay. So for load rating, we used to utilize this equation which is provided in the data book. Load rating at V meter per second equal to load rating at 10 meter per second into V by 10. Okay. We have to calculate this V, which is velocity IDN by 60 in terms of meter per second. We used to calculate this. This load rating at 10 meter per second, this constant which is provided for two different type of belt, we have selected for 949G, and the value is 0.0289 kilowatt. Okay, clear? Understood? So moving on to the next step, what is that? Step 5, determination of this belt width. Okay, as I said earlier, what we used to calculate the belt width by using an equation of design power divided by load rating into number of plies. Okay, I'll already we have calculated the design power and we have calculated the load rating. Now we need to select the corresponding number of plies needed for our design. Okay, for that I have said from page number 7.52 we have to look upon the velocity value which is calculated in the previous step while calculating load rating and the corresponding diameter of driver pulley 18.84 and D equal to 200. Okay, so look upon page number 7.52. Okay, so here it is 18.84 velocity. So the nearest standard velocity is 20. I'm choosing this 20. Okay, and the diameter, what about the diameter, which is 200. Okay, so now go for 200. I'm selecting it to the 180 and 200. I'm selecting the next one, which is 250. Okay, so the velocity is 18.84 on the diameter of driver pulley, which is 200. So I am selecting the 250 for that. But the number of ply is 5 ply. Okay, so apply this 5 plies. Let us apply the 5 ply in the width of the belt equation. We are getting an answer of calculated width of the belt is 264.70. Okay, so similar to the previous problem, select the standard belt width. Here you could note there is a difference. What happens here is the recommended standard belt width for 5 ply exceeds the standard one. Okay, if this is a scenario, you can opt for you can increase the number of plies for getting the design safer. Okay. I'll explain this again. Here the width of the belt is 264.70 and we have to look upon what the standard belt width. Okay, so the standard belt width for 5 ply, it is the maximum one recommended for 5 ply. Maximum standard width is 250 mm. And if in that scenario we are facing the design is not safe. Okay, for what making the safer design, I'm just increasing the number of plies in the belt. So we are selecting it as 6 ply. Okay, for 6 ply, okay, for the calculated value I'm choosing the next standard one, which is 250. Okay, just apply the 6 ply in the same similar equation. I'll show you. Okay, instead of 5 ply, apply it such that it will be 72 divided by load rating of 0.0544 into 6. I'm getting the value around 220 and such that it is lesser than the maximum value, and that is how I have got the total number of the number of plies as 6 on the standard belt with us 250 mm. Okay, clear? Because you may get this kind of differences, you may get doubts. I am trying to choose different problems like how we are going to face it while designing a flat belt. Okay, so the next one, determination of pulley width, similar to the previous one, based on the belt width. So here standard belt width is 250 mm. So look upon page number 7.54. Okay, for 7.54 for the pulley width. Okay, since up to 125 mm, the previous one our limit is up to 125, lesser than 125. Here it is between 125 to 250 mm, the second slab. Okay, you may know, you may take a note of take a note here. It is including 250. So we have got the standard belt width of 250. We are just summing up, adding 25 mm to the existing belt width such that the pulleys are wider than the belt width. So it is 250 plus 25 mm. Okay, 275. And what I have to do again, I have to standardize this pulley width. I have to choose the standard pulley width value based on the design data book, page number 7.55. Okay, go to page number 7.55 recommended series of pulley width. Okay, so here you have got what will be the next standard value after 275. So it is 280. So my standard pulley width value is 280. You have to choose this. If you are making mistakes, not standardizing the value, then there will be error. Okay, it is watched. That is, you have to ensure following the procedure. Okay, we have to standardize. Okay. So then after this, calculate the length of the belt. Sorry. So after standardizing, we have got the pulley width of what? 280 mm. And next one is calculation of length of the belt. Okay. Take a note here. It is cross belt drive. So for a cross belt drive, you will have changes in arc of contact. Okay, the equation of arc of contact and changes in equation of what? Length of the belt. Okay. So page number 7.53, go for the equation provided in cross belt drive. Just a small difference instead of subtraction, here it is addition. And we understand, we do know that we have already calculated the center distance, calculated the diameter of driven and driver pulley. Okay, so using that, we will be calculating the what? Length of the belt, cross belt. Okay, just direct substitution. Even in the small substitution, you may make mistakes in this. That is, some students, they used to calculate the entire thing, 2c plus pi by 2 d plus d plus d plus d whole square by 4c. They used to type it everything at a one stage, and they used to find it error. Okay, if you are well versed in this, apply suitable brackets and calculate the corresponding length. Okay, so it is around 9464 mm. Okay, and after this, what? Apply the specification. Write down all the specifications. Step number 8. What? It starts with belt type, belt width, pulley width, length of the belt, number of plies, diameter of driver pulley, diameter of driven pulley, center distance, and so on. Okay. So the newer thing in this problem is to design what? The pulley, flat belt pulley, cast iron pulley. Here in the question, it is mentioned to design the pulley along with the flat belt. So it consists of a small 4 steps. It starts with dimensions of pulley. So I hope we have discussed that pulley. Okay, pulley for flat belt. The belt runs over the pulley surface. Okay, so I have to calculate the diameter of pulley. Okay, width of pulley, it is represented A. Diameter of pulley, which is represented as D. Okay, thickness of pulley rim, which is T. Thickness. What will be? This is rim. No, what is the rim thickness? Okay, and the next one, dimensions of arms, various arm. The total number of arms here, it is 4 arms. It can be 4 arms, 6 arms, sometimes 8 arms. Okay, and the cross section of arms. Here you could see it is elliptical section. The standardized one, cast iron pulley, which is elliptical section. And the major axis, that is near boss, we could say. This is boss. And the major axis, this will be a major axis of elliptical section. I used to calculate this B, value of B. Okay. And meanwhile, radius of cross section. Radius of cross section, R value, we have to calculate. These are all comes under dimensions of arms. And the next one, dimensions of hub, the middle one. Okay. I used to calculate the dimensions of hub, that is diameter of hub and length of the hub. Okay, what will be my hub diameter and length diameter using the equation. Okay, finally, crown height of the pulley. We have seen a crown. Okay, a smaller crown will be in the pulley, which prevents the pulley which is just moving, which prevents the belt which is moving out of the pulley. Just a small height. It can be either 2 mm or 4 mm based on the that is thickness of the belt. This crown height is placed. These 4 steps you have to include if the design procedure demands you to design the what? Pulley. Okay, quickly we will explore this. Okay. Okay, first one, dimensions of pulley. Okay, for this already we have calculated diameter of pulley, which is what? Diameter of pulley in the sense here it is uppercase D, which is some
Sir,
approach
Ramesh, sir.
driven pulley. 5 more minutes.
Sir, sorry, sir.
Parthiban sir, 5 minutes, 5 minutes.
Yeah, okay, sir. Okay, sir.
Okay, sir, I'll complete it. Okay. So next one, width of pulley. Already we have calculated the pulley width. Okay, which is here width of the pulley. It is here it is mentioned as A. I am just following as it is in the data book. The notation says A, which is 280 mm, and the thickness of pulley ring. Okay, how do I calculate it? How do I calculate the thickness T value? The T value can be calculated by using an equation in 7.57. Okay. So if you have the book, data book, please refer 7.57. Here you have got the thickness value, T value. T equal to D by 200 plus 3 mm for single belt. Here we consider it as a single belt. We have not specially mentioned any about additional belts in the question. Okay. So directly substituting the D value and we have got the thickness. Okay, step one, very simple one. Next one, dimensions of arm. As I said, I do take number of arms from page number 7.56. I used to take total number of arms. Okay, by referring 7.56. Okay, the number of arms. This 7.56 helps a lot for this entire step 2 in pulley design, which is dimensions of arms. Okay, so the number of arms is 4 arms for diameter up to 450 mm. Okay, and it is 6 arm for diameter over 450 mm. So far as in our case the diameter of pulley is 700 mm. So here we are going for choosing the 6 number of arm is 6 arm. Okay, and the next one is cross section of arm. For cross section of arm, by default it is elliptical cross section in the cast iron pulley. Okay, and another one, the third step in dimension of arm is calculation of major axis of elliptical section. That is thickness of arm near the boss, which is 2.94 cube root of AD by 4n. Okay. So what is this? N signifies the number of arms. So here N is 6, and A and D, we know the value of A and D. D is diameter of pulley, A is width of pulley. Okay, by using that, we will be calculating the major axis of elliptical section. And last one, radius of cross section of the arm. This one, R value, radius of cross section, 3 by 4 into B. So B, we will be calculating here B value, which is major axis of elliptical section. Okay, now we will look all this in the step 2. As I said, number of arms is 6. Cross section of arms is elliptical, and major axis of elliptical section, we are applying the equation in the data book and calculating the B value. Based on this, we will be calculating the radius of cross section of arm, which is 3 by 4 into B, and we are getting the R value. Okay, this is step 2. And step 3, dimensions of hub. I need to calculate the hub diameter. So there is an equation in order to calculate the diameter of hub. It is 2 into diameter of shaft. Okay, and calculating the diameter of shaft is exactly similar to how you have I will be calculating the diameter of shaft in the design of machine elements, even strength of materials, using the same equation, power torque equation. So we'll be using what, torque P into 60 by 2 pi n. This is design power. It is not a rated power. Design power in terms of watt. Here we are following the design power in terms of kilowatt. Enter here design power in terms of watt. Okay, gives my corresponding torque in terms of Newton meter. Convert that into Newton millimeter. So design power 62 pi n. N represents then what, speed of the driven pulley. Okay, we have to calculate the n using the velocity ratio. We have already got all the values. Calculate the n. So I have got torque in terms of Newton meter. Convert that into Newton millimeter. and apply this torque in the what shear stress equation, pi by 16 shear stress d cube, and the shear stress is given in the question. It is 120 Newton per mm square. By using that, I will be calculating the diameter of shaft, and the diameter of hub is 2 into diameter of shaft. Simple one. Okay. So the next one, length of the hub as provided in the page number 7.56. It is 2 by 3 into A. Okay. 7.56. You can refer the minimum length of bore. It is length of the hub, which is L equal to 2 by 3 into A. Okay. By using that, calculate the length of the hub. Okay. It is 186.6. Finally, crown height of the pulley. For crown height of the pulley, this crown height, which prevents the slippage or belt getting taken off from the pulley, okay, from passing over the pulley. So for this, we have to utilize from page number 7.55. This tabular column is provided in the page number 7.55. Okay, for the pulley diameter, okay, diameter of 700 mm. Refer the pulley diameter of 700 mm and refer the pulley diameter of 700 mm, refer the pulley width of 280 mm. Okay, you will be getting the corresponding crown height value. Say for the diameter of 700 mm, I'm going behind, it is 630, 710. Okay, 70. And the pulley width of A equal to 280. So it is 280, and this is up to 200, up to 250. Yeah, 280 to 350. So for 700, 710, and for 280, it is crown height H value is 2 mm. Okay. So this is how you are about to design the cast iron pulley. Okay. So take one question as a homework. Try to solve this. This is November, December 2018 9-UST question. Yeah, this one, question 12A. Okay, take a screenshot of it. Okay, complete this. We will discuss the answer about this in the next session. Okay, so that's all about today. In the next session, we will come ahead with some other problems. Okay, some other different problem we will discuss further. If there is any doubt, we will discuss for 2 minutes because I have already taken 10 minutes of the next session. Okay, or else we'll wind up. I request everyone to solve this problem without fail. We will discuss the answer in the next session because even I haven't solved this. Just we have got all the values needed here. Directly they have mentioned it is high speed duck flat belt. You don't want to choose different in the selection of belting. You don't want to go for 4-1. Directly it is high speed duck flat belt. Okay, and the application is fan. Okay, running at a 360 rpm. Okay, so fan running at 360 rpm, which is capital N, which is driven by a 10 kilowatt motor rated power, and the small n driver speed is 1440 rpm. Belt drive is open type, and the space available for center distance is C 2000 mm. Okay, diameter of driven pulley capital D is 1000 mm. Using the given inputs, please design a flat belt drive. We will discuss in the next session. Okay.
Sir,
Yes, sir,
Ashish Kumar, please show all the slides once, sir.
Yeah. Okay,
Sir,
okay.
can you hear me?
Yes, sir. Yes, sir. Yes, possible, sir. Yes. Okay.
Yeah, okay, sir. Okay, sir.
Ashish, let me show. Okay. Either this problem or the previous one. Wait. Yeah. What I will do is I'll share the video link. You could refer it. No issues. Okay. Because I'm already consuming the time for next hour. I'll post the link of this session in the Google Classroom, and later this link will be posted in the our website.